The great thing is the only factoring that you can be given is GCF, so take out a greatest common factor like an x or a 2, or difference of squares. That's it. So, reminding you of what those are. So if I gave you 3, oh boy, the struggle is real. Okay, everyone paying attention so I don't lose you. If I give you 3x squared plus 6x, what could I take out of those two terms? Remember, terms are covered with plus minus. I can take out a 3, because that's to be the smallest, and an x. And when you take out GCF, the operation that you do is what? Yes, it's division. So every time you actually GCF something out is division. So if I take out a 3, I would put an equal sign because this is equal to this, yes? Just like I expect dots. On the test, I did take off some points for the dots. If you didn't do it, I did not take off for sentences, but on the closed book test, if it is a written response and you do not have a sentence, you're losing half the marks. Okay? So when I give you the written response on the test on Tuesday, if you do not write sentences and then you're mad because you lost half your marks, I'm going to say go back to March 14th at 1:22, actually probably 1:10, and go listen to the podcast where I said this. And you all went, yeah, okay, cool. And then you didn't write. Okay? We want to get you in good habits so that when the diploma comes, you don't lose marks in the written response. All right. So I take out a 3, and I take out an x by division. So what's 3 divided by 3? 1. What's x squared take out an x? An x. Then I write the plus sign. Then I say 6, take out a 3. And what I mean by take out is divide. 6 divided by 3 is 2. What's x divided by x? Nothing. So you'd be left with that. We agree? That's how GCFs are. GCFs, right? That's our one option. Our other option is difference of squares. Sometimes it's GCF and difference of squares. It's the two together. What is a difference of squares? Well, difference means what sign?
Minus.
Subtraction, minus. That is the difference sign. So difference of squares. What would a variable be if it was squared? Let's say x squared, right? So one of them would have to be x squared or x4 or x6 or x8. It needs to be an even one. More often than not, it's just an x squared. What is a perfect square when it comes to a number? Anyone have any examples? What would be a perfect square? Yeah. 25. I like it. And 49? Cool. There. I put it on both of them. So do you see how I have a difference, subtraction sign, of perfect squares? Correct? Best definition they've ever, like best defined words they've ever. Difference of squares. It's a difference of squares. It's like the greatest thing ever. The person who discovered it didn't like name it like the Lepp method or something, you know? Like, that's what they did. They named it after themselves. This is a difference of squares. Thank you. Difference of squares. Thank you. That's exactly what it is. So, how do we do these? Remember, we would take the square root of this one. What's the square root of 49? What's the square root of x squared? X. And then what's the square root of 25? 5. And then you're going to get two factors. It's not a trinomial. We don't do trinomial factoring, which is the greatest thing ever for most people. I like factoring personally. But we get two brackets. Whatever is the first term has to come first. Okay? So 7x has to come first in both brackets. The 5 has to come second in each bracket. Do you remember what the symbols have to be? Plus and minus. Does it matter which one's which? No, because it's commutative properties, multiplication. 2 times 4, 4 times 2, right? So, plus, minus. Sure. Can't even keep a straight face. I'm going to do this. Kind of hungry. I have to do this hand. This hand is just not working with me. All right. Example 1. Factor. Whenever you're asked to factor, you must always check for GCF first. Always. Is there something I can take out of 25 and 45? A 5. What about D5, D4? D4. 4. 4 I did. 4. Oh, the struggle's real. This is 4 fingers. Yep, this was 3. Okay, so I can take out 4 because I can only take out the minimum amount, right? I can't take 5 Ds out of 4 Ds. That doesn't make any sense, right? So I always take out the smaller one. So I take out D4. When I take them out, when I take out the greatest common factor, I do division. So what's 25 divided by 5? 5. What's D5 divided by D4? D. Because we subtract when they're the same base, right? Also just thinking, okay, D5 means I have D times D times D times D times D. Okay, so 25 divided by 5 is 5. D5, take out 4 D's is D. 45 divided by 5 is 9. D4, take out a D4. Cancel, right? Do you agree? Okay. What can we take out of B? 9, 12, and 6. What can we take out?
3.
A 3. And then we have K4, K cubed, and a K. How many K's can we take out of each of those? Just 1 K. Now please look and see that you have an equal sign. Do you see how I have an equal sign? Okay. Every time you simplify or do any type of expressions, which means it's an expression because does my original actually have an equal sign in it? When you have variables and numbers, that's an expression. When you have equals to something, that's an equation. This is an expression. Every one of those are equal. Because if I distribute this back in, would I not get back what I had? Is it not true? So this is just a simplified version of this, but are they not actually equal to each other? They're totally equal. This one's equal to this one's equal to that. Because if I distribute it back, I should get what I had. That's why there's an equal sign every step. Okay, I take out a 3K. 9 divided by 3 is? 3. K4, take out a K. Yeah, K3. Plus 12 divided by 3 is? 4. K cubed, take out a K. K squared. Negative 6 divided by 3 is? Negative 2. K, take out a K. She gone. Once you're done taking a GCF, always check if there's difference of squares left behind. Difference of squares is 2 terms. There's 3 terms left behind. Other thing too, guys paying attention, because people do this wrong. When you take out GCFs out of 3 terms, in the brackets behind you should still have 3 terms. So what happens is, everyone paying attention, if I give 2K plus 2, people will take out a 2, and then they'll say 2K take out a 2 is K, and then they'll say 2 out of 2 is 0, and then they do this. If I distribute that back, do I get 2K plus 2? No. So when you do a GCF, you can always do a quick check back. Does it make sense? So if I take out a 2, I need to still have 2 terms with a plus sign sitting in here, do I not? In the bracket, when you take out a GCF, you still have the same number of terms. You don't get rid of terms, you're just simplifying those terms. So 2K take out a 2, I'm left with a K. What's 2 divided by 2? 1. Now if I distribute it back in, would I get that back? Would I get 2K plus 2 back? Yes. So every time you do a GCF, you could double check and see if you're right by pretending to put it back, see if you get what you have. Okay? I want you guys to try C, D, E, F, G, H, I, J, K, L, M, N, O, P. Just kidding. C, D, E, F, G, H. I'm going to do your turn. What can we take out of this one? A 2 and a x. So 8 divided by 2 is 4. X squared, take out an x. I'm left with a x plus 10 divided by 2 is 5. X, take out an x. Gonzo Alfonso, box it. Be loud and proud that you got the answer. Okay, D. What can I take out of D? 12 and 16.
4.
A 4. I have a y and then no y. So can I take out a y? Just because I want to? No. 12 divided by 4 is 3. Y, take out no y's is y. Minus sign. 16 divided by 4 is 4. If you remember GCFs or division, your life will be much better. Okay? And that variables, you're just taking out that number of variables from it. So if I have x squared, I'm taking 2 x's out. If I have x cubed, I'm taking 3 x's out. E, I could take out a 5d cubed, or, because I'm going to be a rebel, I'm going to take out a negative 5d cubed. What does taking a negative out just do? Changes the, rhymes with finds. Starts with an S. Signs. Yes. That's what I did take out. I missed that. Yeah, 15 is better. Not only should you, could you? You should. All right. So negative 15, take out a negative 15, I'm left with a 1. Do I have to write that 1? You have to write the 1 if everything cancels off. So if everything cancels, if it's like 15d5, take out 15d5, and it's a 1, you have to write the 1, okay, if everything cancels. But because I still have d squared left, I don't actually have to write the 1, okay? If I write the 1, am I wrong? No. Will they have a 1 on the multiple choice answer? No. But if you write a 1, you're not wrong, okay? Then we have 45 divided by negative 15, negative 3. So dividing by negative just changes signs, right? Because positives become negatives and negatives become positive, because that's how division works. So d cubed, take out a d cubed, gone. Done. What's up with F? F, she done. Yay! There's nothing you take out. It was a trick question. G, what could I take out? A C. Okay, I have 3 terms here. Do we agree? Terms are separated by plus or minus signs. I better still have 3 terms in that bracket. However many terms you start with is how many you have to have in the bracket. Every time. Okay? You're like, of course that's true. Now you guys will not. When it cancel off, you'll just let it go. Okay? So keep that in mind. When I have 3 terms, I have to have 3 terms. If I have 2 terms in the brackets, I need to still have 2 terms. Because GCF should be able to distribute back. And if you don't have 2 terms to distribute back into, will you get 2 terms back? No. So that's what you need to have. So C cubed, take out a C, I'm left with C squared. C squared, take out a C, I'm left with C. Negative C, take out a C, I'm left with negative 1. Boom. Shakalaka. H, what could I take out? A 6. When I take a 6 out of 6n squared, what am I left with? N squared. Negative 30, take out a 6. Negative 5n. Positive 42 divided by 6. 7. I can't take out anything, but I could take out a what? I could leave it. It could be done. Or I could take out a negative 1. Now the reason why you do that is we're going to be doing rationals where we're going to have certain expressions in numerators, rational and polynomials or whatever in numerators, and then in denominators, and we're going to try and match them so we can cancel them off, right? So sometimes matching them means you have to take a negative 1 out. So we're going to practice that as well. So sometimes all we take out is a negative 1. When we take a negative 1 out, it actually turns those. So we're going to get negative 1 out of negative 7, and we get 7m squared. Negative 10, take out a negative 1. Positive 10m. Positive 17, take out a negative 1. Negative 17. So sometimes taking out a negative 1 makes them match. Sometimes we have to do that. Okay, J, K, and L we're going to do together. J, what can I take out of J? A 9. So do you have the equal signs running down? Every single person, go check now. Do you have the equal signs running down? If you don't, go feverishly back and put in about 900 equal signs. I'm over-exaggerating here. Put all your equal signs. Okay. So 18p cubed, 63p squared, 9p. What can I take out of all of them? 9. P cubed, p squared, p? P. So 18 divided by 9, because GCFs are division. 18 divided by 9 is 2. P, I have 3 p's. I take out 1 p. I'm left with p squared. Minus 63 divided by 9. 7 p squared, take out 1p, p. Negative 9p, take out a 9p. Why did I put a bracket? Anyone? Users? Negative 9p, take out a 9p. Minus 1. Remember, I had 3 terms in the brackets. I better still have 3 terms, right? K. Is there anything I could do to K? What can I take out? A 2. So 18 divided by 2 is 9x squared. Negative 50 divided by 2 is negative 25. And then y squared. What is this? Difference of squares, is it not? How do we know it's a difference of squares? Well, what I always do if I want to know if it's a difference of squares is I pretend to take the square root of them. If I get any decimals or any letters that aren't perfect squares, I can't do it. So if I pretend to take the square root of 9x squared, what do I get? 3x. And then, if I take the square root of 25y squared, what do I get? 5 and y. So those worked out perfectly, correct? If your x's aren't squared, cubed, or squared, 4, 6, 8, if they're not even, you can't do it. If the numbers get you decimals when you take square root of it, can't do it. Okay? So when I took 9, it became a 3, 25 it became a 5, x squared became an x, y squared became a y. And it has to have a difference sign. If it has a plus sign, you're done. You can't do anything about it. There is no addition of squares. You're just done. So here I'm going to be left with 3x at the front of each bracket because it came first. 5y at the back of each bracket because it came second. Plus, minus. My last one is 100z9 plus 50z6 minus 75z5. What could I take out of 100, 50, and 75? 25. Z9, Z6, Z5. How many Z's? Yeah, 5. So I go 100 divided by 25. 100 divided by 25 is how many? 4. Then I have 9 Z's. I take out 5 Z's. How many Z's am I left with? 4. Plus 50 divided by 25, because that's what GCFs do, they divide. 50 divided by 25 is 2. I have 6 Z's. I take out 5 Z's. I'm left with Z. Then minus 75 divided by 25 is 3. Z5, take out Z5. 5 Z's. Gone. Done. Now, you should always know, after you've done GCF, you should always know if you're right. Because if I go and actually distribute it back in, I should get what I have. If I don't, I'm wrong. Correct? Because they are the same thing. One's in simplified form and one is not. Flip over the page. What's on the back? Difference of squares. So we've talked about this already. Remember that whatever comes first has to come first in the brackets. Whatever comes last has to come last in the brackets. You have to have a minus sign in between, and they need to be perfect squares. Sometimes they're not perfect squares because you first have to take out a what? Yeah, a GCF, a greatest common factor. And when you take the greatest common factor out, it works. Let's try the first one together. So it has a different sign and it's 2 terms. So I'm going to check and see if it's a difference of squares. Square root of b squared is what? Square root of b squared? B. Square root of 64? 8. So I'm going to get an equal sign, 2 brackets, because that's what factors are. I get a b at the front of each because it came first, and 8 at the back, and then opposite signs. Now, guys, do you know why we do opposite signs? Why do you do a plus and a minus? Because you were told? Because when you foil and they're opposite signs, it gets rid of your middle term. Is there any middle term on this one? There's a b squared and a 64. Watch. If I foil it back, I told you, if I foil this back, I should get this back, should I not? Well, what's b times b? B squared. Cool. Then I get negative 8b, positive 8b. What happens when I do a negative 8b and a positive 8b? I get no b's. I get no middle term. Correct? And I'm allowed a middle term when I have 2 terms? No. And then like you guys are saying, I need a minus sign, so they have to be opposite. 8 times negative 8 is negative 64. So yes, you need opposite signs so that you get that negative number at the back. That is true. But you need opposite signs so your middle terms cancel. So you get 8b, negative 8b, they're gone. Okay? That's why you do opposite signs. Okay, you guys try these out. If they're not perfect squares, perhaps a GCF needs to be taken out. Always check for a GCF first. If there's something you can take out, you take it out. Like, for example, this one I can take a 4 out, so I'm going to do that first. I can do 4 and 36, even though they're both perfect squares. Try this out. I look at this one. Now, how do I spot a difference of squares? When I used to teach 10, I would say to you, whenever you are given two terms with a subtraction sign in between it, always check if it's a difference of squares. It might not be. It might just be a GCF. It might just be x minus 3, and then it just sits there, right? But two terms with a minus sign, you always check for difference of squares. Now, everyone paying attention, be pencils down. If I can get this into your head, unit will be aggressively easier. Every time you go to factor anything, 3 terms, 2 terms, maybe there's 4, whatever the amount there may be, always check for a GCF first. Can I take a greatest common factor out? It might be a 4, it might be a 2, it might be a 3. If you don't look for that first, and you can actually take something out and you didn't, you will make your life harder. Often not remembering you can take more out. So I will always check for a GCF before I do anything on any question. Okay? So I look here and I say a squared minus 144. I have an a squared, I have 144. Can I take out anything? No. It's a 2 terms with a different sign. So I check for a difference of squares. So I get a and I get 12. They have to go in order. Check for an equal sign, everyone. Do you have an equal sign? I'm going to be crazy about this because you need to have equal signs. Because this equals this, equals this, equals this. And so then we go a first. 12 goes at the back of each bracket. Minus plus, because I'm going to just show you that it doesn't matter. It doesn't have to be plus minus. Okay? Plus minus, minus plus. The only thing that matters is that they are different signs. Okay? We agree? All right. So, 9a squared. I take the square root of 9a squared and I get 3a. Should I be doing this right now? No. What should I have checked for first? A greatest common factor. Is there anything I could take out of 9 and 121? Trick question. No. Anything with an a squared? No. So I actually can't. So then I can go to checking these. This is 11. So I'm going to get 3a plus 11, 3a minus 11. Okay, this one, x squared 81. Can I take anything out of both of those? GCF of any sort? No. Square root of x squared, x. Square root of 81, 9. So I get x, 9, 9, minus, plus, or plus, minus, it doesn't matter. Box your answer so that everyone knows that you know that you're done and you've actually given an answer. I literally need you to box answers, okay? It'll be June, and I'll still have people not boxing answers. Box your answers because you're showing that you know exactly what the answer is that they wanted you to get. Okay? Loud and proud. I did this. I know what I did right. I'm going to box it. Okay, 324 and 289. Can I take anything out of it? No. 324, a squared. What's the square root of it? 18a. And then root 289? 17. So we're going to get 18a at the front. 18a, 17 at the back, plus minus, boxing my answer with an equal sign. I do not want you dock marks for stupid things, right? I want you dock marks because you just didn't know how to do something, okay, I don't want you dock marks at all. But if you're dock something, it's because you don't know how to do it. Not because you didn't have equal signs, you didn't box something, you didn't write sentences. That's not why I want marks being lost, okay? If you oopsie somewhere because you just don't know what you're doing, that's different. Like that happens. Can't be perfect. Perfect is hard. Okay. 81 minus m squared. I'm going to show you two things here. So if you do this one, nothing GCFs out. 81 is 9, m squared is m, and I get 9 minus m, 9 plus m. Now, what if I wanted to cancel off m minus 9? Is positive 9 minus m the same as positive m minus 9? No, wrong signs. 9 is positive, m is negative, and if I said m is positive and 9 is negative, they don't match, correct? So sometimes what you have to do is actually take out a negative 1. Okay? So sometimes you might want to take a negative 1 out, and then you're left with positive m squared, because we can rearrange them, minus 81. So the 81 becomes a negative, and the m squared becomes a positive, and I can just rearrange them. Do you see what I'm saying? Taking a negative out switches signs. Yeah?
Why would you do that?
Because when we do rationals, we're going to have something in a numerator and something in a denominator, and we're going to try to make them match to cancel them off. So if my denominator had m minus 9, and I needed this one to be m minus 9, but it's 9 minus m, they're actually not the same thing. Because this is a positive m and a minus 9, and then this is a negative 9 and a positive m, and they can't cancel. But if I take a negative 1 out, I would now have this negative 1 drag down, and I get m plus 9, m minus 9, and now they match, right? Now that m minus 9 would match. I could do it this way, and just take a negative 1 out of this bracket, couldn't I? And just go negative 1, and then I get negative 9 plus m, and then this one stays the same. Because when you take a negative 1 out, it comes out of one bracket, not both. So then that would match as well, same answer. Do you see how these are the same? They don't look the same, but they are, because this is a negative 1 and a negative 1. Negative 9, positive m, right? And then here, positive 9, positive m, positive m. Because the order in which you write something doesn't matter. It's the sign that's in front of it that matters. You have to take the sign with it. It's attached to it. Okay, 25x squared minus 1. Square root of 25, x is 5x, and 1 is 1, because I can't take anything out. Do you know how many people miss the difference of squares if one of the numbers is 1? A lot of you. If one of the terms, everyone paying attention, I don't say things just to say things. I say things because I see it every single time I give quizzes and tests. Okay? If the difference of squares, one of the numbers is a 1, you guys don't spot it. And then things don't cancel, and you're like, there should be more canceling. And it's always the difference of squares that you're missing when more could cancel. And it's often because one of them is a 1 and it's not blatantly, obviously, a perfect square, right? 4 is a perfect square. 9 in people's heads. 25, 36, 49, 81. Those are kind of perfect square numbers. 1 people forget is a perfect square. Okay? So we're going to get 5x, 1, 5x, 1, negative, positive, positive, negative. H most people will do wrong because they don't check for GCFs first. What could I take out of 4x squared minus 36? We take out a 4. When I take out a 4, I'm left with x squared minus 9. And that's a difference of squares. So I get 4, x plus 3, x minus 3. Where most of you will be sitting, I'll show you what you guys would have done. So most of you will take square root, and you will get 2x plus 6, 2x minus 6, and you'll say you're good. You're not good. What can I take out of this bracket? A 2, and then I would be left with x plus 3. What can I take out of this bracket? A 2, and then I'd be left with x minus 3. And then the 2 and 2 can join, because these are all multiplied. 2 times this and 2 times this, right? 2 and 2 is a 4, and then you get x plus 3, x minus 3, which is the exact same as my answer, but most people will mess up because they won't spot they can take a 2 out, or they don't know what to do with those 2s when they do take them out. Like, just leave them here. Okay? So always check for GCF first. Pardon?
Do you multiply or add?
You multiply, because there's no plus signs in between here. This you could technically put brackets around these babies, and it'd be like 2 times this times 2 times this, and 2 and 2 is 4. Okay, yeah, it's multiplication. Yeah, 2s aren't really the most helpful because you could add them or multiply and get the same answer, but it's multiplication. Okay, we're going to flip over. We're going to flip down here to non-permissible values first. What is the only thing you're not allowed to divide by? Square root, can't do a negative. That's where your negative's coming from. What can you not divide by? 0. You're not allowed to divide by 0, right? And until rationals came along, everyone paying attention? Until rationals came along, life was good. Because you guys had fractions, which would be like 7 over 4. Can the denominator be 0 if it's 4? No problems, correct? When do problems happen? Problems happen when I start putting variables in your denominator. Like such as this. X plus 1 over 5x squared minus 5x. You see those variables down here? That means there's a number I could probably fill in for x that would create my denominator to be 0. And if that happens, that's a problem. X can't be that number. Okay? So whenever you have variables in your denominator, you have to check for non-permissible values, values that are not permissible, aka restrictions. They can be called restrictions or non-permissible values. So if I look here, and they just want, consider the rational expression x plus 1 over 5x squared minus 5x, determine the non-permissible values. Do I actually care about the numerator? Can my numerator be a 0? Can I go 0 divided by 5 in my calculator? 0 divided by 5? Punch it in. 0 divided by 5. This. What's my answer? 0. Am I allowed to have a numerator that's 0? Yes. Okay, what if I do this? 5 divided by 0. Type that into your calculator. It gets mad at you. Because we can't divide by a 0. Right? So our denominator can't be 0. Can our numerator be 0? Yes, our numerator is totally fine to be 0. The answer would be 0. Yes? It's our denominator that can't. So if all they're asking for is non-permissible values, I just need to reduce my denominator and go from there. So I have 5x squared minus 5x. That's what I'm looking at, the 5x squared minus 5x. Can I take out a GCF? 5x squared minus 5x. Can I take anything out of that? A 5 and a x. So I'm going to write that in this denominator. So it's going to equal 5x. And then when I take a 5x out of 5x squared, what am I left with? X minus 5x divided by 5x, 1. Now, no, you can't. But we don't want to cancel anyways. We want to talk about restrictions. The restrictions are only the denominator, yes? Okay. I know in the past you've never done this. What way I'm going to ask you to do brackets here. But I'm going to ask you to do brackets in this way because halfway through teaching 30-2, I realized people do not know how to cancel properly. How can I make it better? And so what I wanted to do is show you what is separate things. Okay? So this x and this 1 are attached. Anything with minus or plus signs is literally sewn together. It's like the minus or the plus sign. Everyone paying attention because people get this wrong. The minus or the plus sign between two terms, that's like literally super glue. Those things are stuck. They can never be pulled apart. So this x and this 1, can I cross off the 1 or just cross off the x? No. I can only cross off x minus 1 if there was a matching replica, x minus 1 in my numerator, and then I can cross them off. Because this here, my friends, is a binomial. Binomials can only cancel off binomials. Two-term functions, two-term expressions, two-term expressions. The 5 and the x are multiplied together, we agree? Okay. Can we separate them? Yes. So what I will actually ask you to do is if you have two things multiplied, I will ask you to put brackets around them separately. I know that sounds weird, please do it. The people who follow along with what I'm saying will often do really, really well in this unit, and the people who don't do that will cross off wrong things. Yeah. If you take a 1 out, you're going to still have x plus 1.
Yeah. You can just cancel out the bottom.
The bottom is x minus 1. Yeah. Remember, you take them out of GCS by division. It's not subtraction. Right? All right. So the top here it would actually be in brackets as well because the x and the plus 1 are attached. Correct? The only thing I can take out of them is a plus 1, and if I take a 1 out, it doesn't change anything. All right. I need to figure out what the values are that if I plug them in for x, my denominator would result in a 0. Yes? So actually, if I plugged a 0 into this bracket and times it by x and x minus 1, it would become 0, right? If I plugged a 0 in here, 5 times x minus 1 would become 0. If I plugged a 0 in here, it would become 0, right? So the way to check for non-permissible values is to take all your separate brackets and set them not equal to 0. So the first bracket I have, and I don't care about the numerator. The numerator can equal 0. That's totally fine. We proved that, right? 0 divided by 5 is 0. Totally good. It's the denominator. So we'll take the 5 first, and we'll say 5 can't equal 0. True. That's really all. Yeah, that's a true statement. 5 can't equal 0. It's 5. Does it have a variable? Does the 5 have a variable? No. This will not create an NPV. So if you just have a number can't equal 0, that's just a true statement. Yay! But no NPV is made out of it. Okay? What's my next bracket? X. So I'll say X can't equal 0. True statement? And it's done. And I'll prove to you why these actually work. Okay? What's my next bracket? X minus 1 can't equal 0. How do I solve for it? I add 1. And I get X can't equal what? True statement? How do I know that I'm right? If I plug those values back into my denominator will turn to a 0. Because if I'm saying it can't be 0 and it can't be 1, then if I plug those back in, my denominator should be a 0, right? What is my denominator to begin with? 5x squared minus 5x. So I'm going to check these. So the first one I'm going to check is x can't equal 0. Well, let's see if that's true. So if I plug a 0 into this denominator and it results in 0, I'm right. Because I'm saying it can't be that because it would turn my denominator to 0. So let's fill in the 0, the first one I solved for. 5 bracket 0 squared minus 5 times 0, which results in 0 minus 0, which results in nothing, 0. So if I did actually use x equals 0, my denominator would be 0. Is that not true? So that's why x can't equal 0. It would make my denominator be 0. Let's check the other one that I said it can't be. I said x can't equal 1. Well, let's plug it in. So we have 5x squared minus 5x is my denominator. If when I plug it in, it gets me a 0, I know I'm right. Because it can't be that because my denominator would be 0. So I go 5 bracket 1 squared minus 5 times 1. 5 times 1 squared is 5. Minus 5 times 1 is minus 5. And I get 0. So if I plug in a 0 into this expression, will I get a denominator of 0? Yes. If I plug 1 in for x, will I get a denominator of 0? Yes. So x can't be those because it would make my denominator be 0. Does that make sense? It cannot be those two values because if I plug those in, my denominator will be 0 and I'm not allowed to have a denominator of 0. So what are my non-permissible values? X can't equal 0 and 1. Then here it says state the restrictions. X can't equal 0 and 1. I did this for effect. They're the exact same question written differently. The restrictions are what x can't be. The non-permissible values are what x can't be. It's just the same thing asked in a different way. So let's look down at example 2a. Determine the non-permissible values restrictions of the following. Do I care about the numerator at all if it just asks for restrictions? No, because the numerator can be any number. It doesn't matter. It's just my denominator. I have a minus 1. Can I take anything out of a minus 1? Is there any GCFs, difference of squares? Nothing. No. And the a minus 1 is attached, correct? By super glue. Remember, a minus 1 and a plus 1 is super glue. So the a and the 1 are super glued together. We agree? So I now, if that's all I have, I just say, okay, well, a minus 1 isn't allowed to equal what? What's it not allowed to equal? 0, because our denominator can't be 0, right? The a minus 1 can't be 0. If a minus 1 is 0, my denominator would be 0, and we'd be in trouble. And now I just solve. Add 1. Add 1. A can't equal what? 1. Box it, because I'm happy, because that's what it can equal. To prove that I'm right, I take that number and I plug it into the denominator. And if the denominator equals 0, I am right. It can't be that. So let's try it out. A can't equal 1. Okay, so I'm going to put it in. 1 minus 1 is 0. It would make my denominator 0, wouldn't it? So I know I'm right. Does that make a little more sense? Let's look at B. I only look at the denominator if I'm talking about non-permissible values. So I have 2k squared minus k. Is there anything I can do to that? What can I take out? A k. So I have 2k squared minus k. That's my denominator. I could take a k out, and I would be left with what? 2k minus 1. So I can actually rewrite this rational as 4 over k in brackets 2k minus 1. Can I not? Are those not the same thing? One is a more simplified form. So now I'm going to have two things that I have to actually find out because there are two bracketed things in my denominator, yes? So I have to check two non-permissible values. So I'm going to do this one first. I'm going to say k can't equal 0. Cool, box it. That one's done. There's no solving for it, right? Then I have to take my second bracket and say 2k minus 1 can't equal 0. How do I solve? That's k by itself. Reverse bedmaster, right? So I have to move the additions and subtractions first. So I add 1. And I get 2k can't equal 1. And then how do I get 2 times k moved away? Divide by 2. So k can't equal 1/2. Now I know I'm right if I plug those back in and I would get 0. We agree? So if I go plug the 0 back in by itself, I'll get 2 times 0 squared, which is 0 minus 0. So that would result in a 0. If I plug a half in, I'm actually going to get 2 bracket 1. I want you to do this. Go to your calculator and plug in 2 bracket 1/2 squared minus a half. So we're checking it. And you can just type that in, right? Just make sure you put your fractions in brackets. You have to put this one in brackets too. 2 times 1/2 squared minus a half. And we get 0, don't we? So then I know I'm right. So k can't equal 0 or a half. Someone has a hand up? Yeah.
Would you rather it in a fraction or the decimal?
So I'd rather it in a fraction if the decimal doesn't terminate.
Okay.
So if the decimal's like 0.33333, I don't want 0.3 rounded. I don't want any of that. I want a third. But if it's a half and it's 0.5, those are equivalent to me. As long as it's terminating, stopping decimal, you're fine.